All right, so now that we have a understanding of the three different scenarios for finding probabilities for a normal distribution, let's take a look at some examples. All right, so these questions just want you to find the area of the shaded region. So now there are making some assumptions that the bell-shaped distribution is a standard normal distribution. So the area is equal to 1, so we can use our tables, and that's the important thing we need to do this. So first thing we notice is that z is equal to a positive 0.75, so we'll get our positive z-squared table out, and let's look it up. So positive 0.75, so 7734. Now remember, we can just read it off from the table because this one is shaded to the left and the table shows us area shaded to the left. So that one is done. Now for this one, we got an area between two z-scores, so we're going to have to go to our table for both of these. So we got an area for this one and an area for this one. So our negative z-score, negative 0.60. So let's see here. I'm going to go down. Negative 0.60 is the first column, so 2743. And then we need our positive 1.2 z-score. So 1.2, and again, zeros in the first column, so 8849. All right, so we found the individuals, and so now the last thing we should do is subtract. So the overall answer, let's see what we got. 0.8849 minus 0.2743 equals 6106. And that's it. So nice and quick. All right, let's do a couple more. So now it's a little bit more wordy, but we still can frame it the same way. Assume that thermometer readings are normally distributed, so bell-shaped curve, with a mean of 0 degrees Celsius and a standard deviation of 1 degree Celsius. So again, those conditions all have to be met before you can use the tables. A thermometer is randomly selected and tested. In each case, draw a sketch and find the probability of each reading. So we want a probability that it's less than negative 1.05. Now technically this would probably be degrees Fahrenheit. And same thing here. So that's what they're looking for, but let's draw a picture. So less than negative 1.5, so zero's in the middle, so negative 1.5 better be over here on the left. And because it's less than, we know we got a shade to the left. So we're expecting a smaller probability. So let's take a look at our table. We want to use the negative. So negative 1.50, so 0.668. And that's what we expected. We expected a small answer based on our diagram. All right, let's take a look at the next one. Greater than 2.22. So again, a quick sketch. 0 in the middle. 2.22 better be on the right side. And because it's greater than, we got a shade to the right. So if we go to our table, look up our positive z-scores. So 222. So there's 2.2. And there's the other two. So we got to cross-reference these ones. So it looks like 9868. And then we're done. Hopefully you're saying no. Remember, because it's shaded to the right, we have to go that one extra step and subtract what we just found from 1. So when we do that, we're going to get 0.0132. All right, so far so good. Let's take a look at the last one and then we'll end this video. So we got between 0.50 and 1.00. So if we get our diagram again, 0 is in the middle. Now 0.50 is positive, so we're on the right side. And 1.0 is also on the right side. And we want between them. So where do we start? Remember, start with the one furthest to the right and then find the probability of the one on the left. So when z is equal to 1.00, we get a probability of what? Well, let's get to our table. 1.0, and then the first column is 0, so 8413. And then when z is 0.50, 0.506915. And then the last thing we got to do is subtract them. And let's make sure we do it right. $14.98. So pretty close to 15%. Now, keep in mind, just like we said before, you're not going to want to write your answers as percentages unless they ask you. So always write your answer, your probabilities as decimals like this. 4 decimal places in this chapter. 3 in the previous one, but 4 in this one. All right, so we'll stop there, but in the next video, we're going to see how we can reverse this process. Fun, fun, fun. See you soon.